Okay, so are you ready to dive into the world of acids, bases, and pH?
Let's do it.
I'm super excited about this one. It's seriously cool chemistry. And you know me, I love this stuff. We've got two sources lined up today.
Okay.
One's going to break down all the fundamentals of acids, bases, that pH scale, all that jazz.
Right.
And then the other one goes into this really common lab technique called titration.
Uh-huh.
I think this is going to be a good one. I'm ready for some aha moments.
Yeah, you know what's interesting about this is how many connections there are between these like really simple chemical concepts and how they actually impact like everything.
Right.
Like our bodies, the environment. I think people will be surprised.
Totally. Okay, so let's just jump right in. Our first source is acids, bases, and the pH scale. And I feel like we got to start with the pH scale, right? It's that thing that tells you how acidic or basic something is, right?
That's it.
0 to 14.
Exactly. And it's just like a report card.
Yeah.
7 is neutral, right in the middle. Anything below a 7 is acidic, above it is basic.
Okay.
Big difference between lemon juice and baking soda.
Yeah.
Two totally different sides of the pH spectrum.
Yeah, for sure. Okay, so this is where things get a little crazy. It's not just a normal number line. The pH scale, it's logarithmic, right?
Right.
So, like, each number increase is a tenfold change.
Exactly.
So it's not like 3 is just a little bit more acidic than 4.
Yeah, 3 is 10 times more acidic than a pH of 4.
Yeah.
And 100 times more acidic than a 5.
Wow. It's like exponential. Okay, so then what makes an acid an acid? What's going on there?
So acids are these little proton donors, right? So they release hydrogen ions, H+, when they're dissolved in water.
Okay.
And the more of those that they give up, the stronger the acid is.
So it's like a spectrum, like some are like, take them all.
Exactly.
Yeah,
And
exactly.
others are like, eh.
Right, exactly. So
Yeah.
hydrochloric acid, HCl, strong acid,
Okay.
gives up all its hydrogen ions. It's completely ionized in the water.
And then you have your weaker acids, like acetic acid, that's the one
Right.
in vinegar.
Okay.
And those only partially ionize.
Okay, so the hydrogen ions that are being released, those little protons, they don't just like float around by themselves. Right?
No, they don't like to be alone. So they bond with water molecules, and they form what's called a hydronium ion, H30 plus WIM.
Okay.
And the concentration of those hydronium ions, that's what actually determines how acidic a solution is.
So those are really calling the shots.
They are.
Okay, this is what I'm really excited to talk about. What about acids in everyday life? I always think about lemon juice. What else?
Yeah, so you know acids taste sour.
Yeah, for sure.
That's the acid. They turn litmus paper red. That's how you test for them in the lab.
Right, right, right.
And if you react an acid with a metal, watch out. You're going to get hydrogen gas.
Okay. So we got our vinegar, lemon juice, battery acid, all the classics.
Yep.
What about on the other side of the pH scale? What about bases?
Bases. So bases are the acceptors. They're the opposite, right? So they accept those hydrogen ions. They release hydroxide ions, OH, when they're in water. And just like acids, how strong they are depends on how many of those hydroxide ions they let go of.
So it's this constant like back and forth
Yes, exactly.
between the acids and the bases.
It's a delicate dance, yeah.
Yeah. So the hydroxide ions, those are really key for a solution's alkalinity.
Absolutely. The more hydroxide ions, the higher the pH, the more basic it is. And one little tip, if you're ever looking at chemical formulas, a lot of times you'll see bases, they end with hydroxide. So NaOH, KOH, it's kind of a clue,
Okay, that's a good little hint there.
a little cheat sheet.
Look for that hydroxide at the end. So are bases as common as acids in our daily lives, I guess? What are some things that we would recognize?
I think you'd be surprised. So many cleaning products have bases in them. Soaps, detergents, even oven cleaners.
Yeah.
Antacids, those have bases in them to neutralize stomach acid.
Right, to like balance it all out.
Exactly. And ammonia. Ammonia is a base.
Yeah.
It's used in cleaners. It's used in fertilizer. And if you're a gardener, you might have even used calcium hydroxide.
Okay.
That's another base to help balance out soil if it's too acidic.
Interesting. Okay, so they really are kind of all over. Who knew that something like so small, like a hydrogen ion or a hydroxide ion,
No, it's crazy.
could have such a big impact
It really is.
on everything?
Yeah, it really is amazing how these teeny little things make such a big difference. But speaking of how these things apply to everyday life, our next source is all about titrations.
Okay.
Introduction to titrations. And this is a really cool technique that's used in so many different areas like medicine environmental science.
Hmm.
It's used all over the place.
Okay, yeah. I have to say, when I hear titration, I always get a little intimidated. Like, it sounds very serious, like I should be wearing a lab coat and,
Yeah. Yeah,
what is it?
it's really not that intimidating. It's really all about precision. It's about balance.
Yeah. So we're using acids and bases, but we're using these tools and stuff to figure out the concentration of a solution.
So it's like a chemical balancing act in a way.
It is. It absolutely is. And just like if you were like baking something, you need those precise measurements for quality control, for analysis.
Right.
Whether we're talking about like, is your drinking water safe? How potent is this medication?
Okay.
Even like if you're making yogurt, how do you know it has that tang?
Wow. Okay, so it's a lot more versatile than I thought. How does it actually work?
Okay, so imagine you have two solutions. One of them you know the concentration of, that's called your titrant.
Okay.
And then you have another one where you don't know the concentration.
Mm.
And you slowly add the one that you know to the one you don't know, drop by drop, until you hit this perfect balance. And that's what's called the equivalence point.
The equivalence point. So that's like
That's the sweet spot.
that's the finish line. What happens at that point?
That's where they've completely neutralized each other.
Oh, okay. So you've added just the right amount of one to completely balance out the other.
Okay, got it, got it. And we must use some pretty specific tools to, like, actually do this, right?
We do, yeah.
Sure, yeah.
You got your beaker, your flask, all that, but then it gets fancy. You have a burette. That's that long glass thing with a stopcock at the bottom. So you can really do your drop by drop.
Okay,
And then a pipette to get your exact measurements, your Erlenmeyer flask,
okay.
all the classics.
I love it. How do you actually know when you've reached that equivalence point, though?
So that's where things like a pH meter come in handy, or an
Yeah.
indicator.
Okay.
So a pH meter can tell you exactly what the pH is at that moment.
Mm-hmm.
And indicators, they actually change color.
Oh, wow.
They're like the chameleons of chemistry.
Okay. So you can, like, visually see it.
Yeah. Yeah.
That's so cool. Okay, so what's the whole process look like from start to finish?
So safety first, of course, right? Goggles, lab coat, all that. You prep all your solutions, make sure they're measured out exactly, because remember, this is all about precision. You load up your burette with your titrant, get your analyte measured out in your flask, and then the slow drip begins. Drop by drop, and you're watching that pH meter or your indicator, just waiting for that sign that you've hit the equivalence point.
It's a process.
It is.
That's amazing. Okay, so we're doing all this. Is there a way to actually, like, visualize how the pH changes during this?
Yeah, so that would be a pH titration curve.
Okay.
It's basically a graph that shows you exactly how the pH of that solution changes over time
Okay.
as you add more and more. And then you can see when you hit that equivalence point because it changes drastically.
Okay.
There's a huge jump.
Oh, wow. That's cool. So what's the chemistry that's actually happening during all of this? Like, what's happening to actually neutralize everything?
So it all comes down to those reactions between acids and bases, right? We call neutralization reactions.
Hmm.
That's where acids and bases react and they form salt and water.
Hmm.
And in that process, they basically cancel each other out.
Okay.
Like they were rivals, but now they're friends.
Yeah.
And a lot of times, these reactions are what we call exothermic, meaning they release heat.
Oh.
And then the final pH, that depends on the strength of the acid and the base that you used.
Wow. Okay. So this is happening in labs, but where do we actually see this being used in the real world?
So many places. So let's talk about water,
Okay.
something we all need. Titration. It can actually help determine the alkalinity of water.
Hmm.
That's how we know if it's safe to drink.
Wow. Okay. So it's really important for, like, our water supply.
It really is.
What about, like, other industries?
Agriculture. They use it to figure out the acidity of soil.
Okay.
Food industry.
Hmm.
To figure out, like, how acidic is your coffee or, like, how much salt is in something.
Right.
Pharmaceuticals. Huge for that.
Wow. Okay. It's everywhere. I'm learning so much. So if someone's out there and they're thinking, this is cool, I want to work with this, what kind of career paths are there?
Well, if you really like precision and you want to be on the front lines, you can be a lab technician.
That's so cool. Like, honestly, if you're someone who likes to bake or you're, like, really careful about adding spices when you're cooking, you're basically doing titration, right?
Yeah, kind of, yeah.
That's really cool. Okay, so it's everywhere, from making sure our water's clean to our food and medicine. It's keeping us safe.
Absolutely. And it all comes back to, like we were saying, those interactions between acids and bases.
Mhm.
But, as much as I think titrations are cool, I got to say, one of the things I always find myself going back to are buffers.
Oh, yeah.
Those are the system, they resist those pH changes, right? It's like, they don't want the pH to change too much.
Yeah. Our sources mention them, but I got to be honest, I'm not totally clear on them. How do they work?
So buffers are cool because they're both.
Right.
They're made up of a weak acid and its conjugate base, or a weak base and its conjugate acid. And those two things together, they can neutralize any acid or base that gets added so the pH doesn't go crazy.
So it's like the weak acid and its conjugate, they're like working together
Yeah, it's like a team.
to like maintain
Total teamwork.
order.
Yeah, if a strong acid comes in, the base is like, oop, neutralizes it. If a strong base comes in, the weak acid is like, not today.
They keep things balanced.
Okay, so it's back and forth,
Yeah,
constantly happening.
constantly.
Okay, so where do we actually see this at work?
Well, think about your blood.
Okay.
Your blood has a buffer system.
Oh, wow.
That's how it stays at like 7.4 pH. If it didn't have that, we would be in big trouble.
So they're keeping us alive right now.
Pretty much, yeah.
That's amazing.
Yeah.
What about other places, like not in our bodies?
A lot of your personal care products, shampoos, lotions, contact lens solution even.
Oh, right. Okay. They have buffers in them so that they're not too harsh on your skin or your eyes.
That makes so much sense because I've always wondered about that. How come it's not just like messing everything up?
Right.
So it's the buffers.
It's the buffers. And then the food industry uses them too, so your food stays good,
Yeah.
like your baked goods or sauces, drinks.
Oh, interesting. To keep it from going bad.
Yeah,
Okay, so it's really everywhere.
it's everywhere. You just don't think about it.
We've covered so much. It's amazing. We started with acids, bases, pH, then we went to titrations, then buffers. Wow, there's so many connections between chemistry and like our daily lives.
Yeah, and we don't even realize it most of the time.
Yeah, it's all happening behind the scenes, but it's pretty amazing stuff.
It is.
So I hope you learned something today. I feel like I definitely have. This was a lot of fun. Go out there, keep exploring, and we'll catch you next time on The Deep Dive.